run through on instrumentation amplifiers. Let's start with the basics. Okay, here we have a nice little circuit, and what we can see in our design here, this is a symbol that we're using for an instrumentation amplifier. Okay, it's the same symbol as we would use for an op-amp, but it's slightly different. Voltage 1, voltage 2. What we can consider happening inside the instrumentation amplifier is the signal goes to a mixer, we add, and we subtract. So this is looking at the difference between the two signals V1 and V2. We apply that through a gain, and in this case this is AD, sometimes referred to as ADM, and we add that to a combined signal, and we will call that voltage out or V out. If you also look at the input, we take half of the input and we sum it with half of the input on the other line. So what we're looking at is the average of the combined signal between the two. We then have a different gain here, and we're calling that ACM, common mode gain inside the design. We then sum that with the original and we get to my V out. So it's very easy to arrive at an expression for the equation V out. V out is differential mode gain AD or ADM, V1 minus V2, the voltage difference between the two inputs, plus ACM, common mode gain of the average V1 plus V2 over 2 input signal. So that's one of the absolute key equations for this design. Second thing that we actually really need to know about for the instrumentation amplifier is how good is the common mode rejection ratio. How good is the amplifier at amplifying the different signal and rejecting the common mode signal? And that's defined as the common mode rejection ratio, which is the differential mode gain divided by the common mode gain. The larger this number, magnitude only, is what we were actually trying to achieve. So common mode rejection ratio is usually expressed in dBs, so put that into dBs. We would normally take whatever that value is, 20 log to the base 10 of the differential mode gain over the common mode gain. And again, that gives us a very large number. So some of the op-amps that you might see might have a common mode rejection ratio of like about 80 dBs, 90 dBs. Something crude might be 50 dBs, and something very advanced might be 100 dBs. Okay, that's just the basic introduction, just to get you up to speed with writing out the basic equations, V out, and what common mode rejection ratio actually is.